Okay, so welcome back. Thanks for joining me again. Hopefully this is really helpful. Thanks for taking time to make sure you learn things well and that you understand. We're going to take a look at problems 9 and 10. I think these are one of the more challenging problems for a lot of people because these are things that we should know coming into geometry, but a lot of people don't know them. And that's not always our fault. Sometimes our teachers just haven't done these things. So let's see what we got here. Yeah. So we got this little strange shape right here, and I want to find the area of the shape, and I would also like to find the perimeter of the shape. So area here, perimeter here. So the first thing is we have a composition of shapes. We got a bunch of stuff going on right here. So I think the easiest thing that I could see is I could break this up into a triangle here and a triangle over here and a rectangle or maybe a square in the middle. So keep in mind that we know that the area of a triangle should be 1/2 base times height. So on this particular triangle, what I could see, so I'm going to call this triangle number one. Triangle number one. I could say that if we had 1/2 the base times the height, let's see, I think I'm going to call the base of this triangle 1, and I'm going to call its height 1, 2, 3, 4. Okay. So that would mean the area of that particular triangle is 1. Now for shape number 2 right here, I have a square, and the area of a square is just its length times its width, or you could say its base times its height. So the base is 1, 2, 3, 4, and its height is 1, 2, 3, 4. So number 2, I would just say area is base times height. That's 4 times 4, which is 16. That's pretty simple. And then for number 3, we have another triangle. Triangle number 3 over here. I'm actually going to call this the base, which is 1, 2, 3, 4. So again, 1/2 the base, which is 4. And its height is 1, 2, 3, 4, right there. 1, 2, 3, 4. It might even help if I drew a line right there so you could see that the base is 4 and its height is also 4. But 1/2 of 4 times 4, well, 4 times 4 is 16, and half of that is 8. So it appears that the area would be the sum of 2, 16, and 8. And if I added all those together, 2 plus 16 is 18, and 18 plus 8 is 26, and we're done. We found the area of our composite shape. Now, as it turns out, those little things were very, very helpful to me to find the perimeter. Because if I look at this shape right here, I'm going to draw that right here so we can see that. I purposely made myself a nice little right triangle. And I already know that this part of my triangle is 4. And I also know that this little piece right here is 1. So I could say, if I called this C, if you will, I could say A squared plus B squared equals C squared. 1 squared, of course, is 1. 4 squared is 16. So together that makes 17, and that would make C the square root of 17. Now, what I'm going to do is I'm going to actually draw that right on my figure, and I'm going to say that this portion of my graph from A to E is perfectly root 17. I know that piece. Now, keep in mind, I'm going to be walking around this because to find the perimeter, I need to do that. I also know that I've got this segment from here to here that I already figured out that if I walked that, I would walk precisely 4. Now, when I come to the next little piece, as I walk my way around this, I have another triangle right here that I could use. And so I'm going to draw that right here so that I could put some numbers on it. And I know if I count, I go 1, 2, 3 up. And I go over 1, 2, 3, 4. And again, I'm just using C for the hypotenuse because we often do that for the Pythagorean theorem. So I've got 3 squared plus 4 squared equals C squared. Well, this time around, something really, really nice happens. It does not happen all the time because I know 9 and 16 makes 25, and I happen to know that if I take the square root of both sides, the square root of 25 is just plain old 5. Well, that's a really, really nice number. So I just found out that the length of this portion of my figure as I work my way around is perfectly the number 5. Now I got one more triangle right here that was 1 by 4. So this part right here is 1. This part is 4. But you know, that's interesting. I'm not going to redo that problem because I already did that problem over here. I got a 1 and a 4, and I got root 17. This is really the same triangle. It's just rotated. So this has to be root 17. So I've got this is root 17. I think I'll go ahead and color that one maybe blue. And then the only thing left to get myself home as I walk my way around this shape is to find the length of AB. And AB would be the length 1, 2, 3, 4, 5. There we go. And so that would make my perimeter. And I wish I had a little more space, so I'm going to just write a sticky note right here so I can actually get enough room to write that in there. My perimeter, actually, I'll put it right here maybe. My final answer for my perimeter is equal to the square root of 17 plus 4 plus 5 plus another root 17 plus an additional 5. Now, I could call 5 plus 5, 10, and 10 plus 4 is 14. I got 14, right? And I've got 2 of these root 17 guys. But we also ask you to give our answer to the nearest 10th, which means we're allowing you to use a calculator to come up with a decimal approximation. So my calculator says 14. Now, again, I could type this all together as one line, or I could just use my simplified version. I'll get the same answer. Plus 2 times the square root of 17. And when I got that, I got 22.246. But rounded to the nearest 10th, 4 would round down, so I would call that perimeter approximately 22.2. And again, if you have doubts, it's fine. We could say the square root of 17 plus 4 plus 5 plus square root of 17 again, and then plus an additional 5. And we should get exactly the same answer, which we did. All right. Well, I hope that was helpful. And that was problems 9 and 10, looks like. And hopefully we're ready for the test coming up. All right. Have a good day. Bye-bye.